We're going to go ahead and review the second fundamental theorem of calculus, and by this point, I'm assuming that you have some sort of basic understanding of the first fundamental theorem of calculus. Let's check it out. So here's the first fundamental theorem of calculus, that when you have an integral from a to b, then that is going to equal to the antiderivative evaluated at b minus the antiderivative evaluated at a. It's actually quite fascinating that this is the problem on how we solve all these definite integrals. And here we have the second fundamental theorem of calculus, that when you're taking the derivative with respect to x of some integral from a to x, where a here is a constant, of the function f of t dt, that's simply going to equal to the original function evaluated at x. So let's go ahead and talk about the proof for that. So let's just break this down a little bit. Let's go ahead and just focus on the integral in this case. So we have the integral from a to x of f of t dt. And according to the first fundamental theorem of calculus, this is simply equal to the antiderivative at x, which is the upper bound minus the antiderivative evaluated at a. Again, this is simply the first fundamental theorem of calculus, where you take the antiderivative evaluated at the upper bound minus the antiderivative evaluated at the lower bound. So here we are. Now we have to just go ahead and take the derivative in this case. So we're taking the derivative of this function here. It's a simple sum and difference rule. So we take the derivative of the this function here, which is simply going to be f of x minus, this is a constant because f evaluated at some constant will be a constant. So when you take the derivative of a constant, that's just 0, and that is why this is equal to f of x. This is the second fundamental theorem of calculus, but there's definitely more extensions to that. So we basically answered the question that you were asking of what happened to that constant value. It just went away because we took the derivative of a constant. But again, as I mentioned, there is extension. So in order for us to understand this particular problem, because we had e to the power of 2x, not just x, we need to understand something else. So this is the second fundamental theorem of calculus extended. So we're taking the derivative of an integral from a to some function g of x of f of t with respect to t. And this is equal to f of g of x times g prime of x. So basically it's f composite g times the derivative of what's inside. So sort of like a little chain rule. Now, why is this true? Well, don't forget, we're going to take the derivative of this particular value, but this right here is the antiderivative evaluated at g minus the antiderivative evaluated at a. And of course, if we take the derivative of this, and this is just going to be by chain rule f composite g times the derivative of what's inside, and that's why I have that g prime of x minus 0. So once again, this right here is an extension of the second fundamental theorem of calculus, just a little bit different. We are typically taught this one just because it's much easier for us to understand, but of course, there could be other situations. So if we're using the second fundamental theorem of calculus extended, then this right here, we're taking the derivative with respect to, this should be with respect to x of this integral here. So this is just going to be the original integral evaluated at e to the power of 2x. So this is going to be e to the 2x cosine of e to the 2x times the derivative of the function that I plugged in, because this is a composite function. This is f of g of x, that's my f of g of x, times g prime of x. So I need to take the derivative of the value that I plugged in, and that's going to be 2e to the 2x. And that's how we will solve this particular problem. But again, there's other examples. So now what happens when you have the derivative with respect to x of some integral from h of x of g of x of f of t with respect to t? So try to pause the video and think about what this would be. Pause it. Pause. Okay, I'm going to show you. This is going to equal to f of g of x times g prime of x minus f of h of x times h prime of x. Now, why is that the case? Well, we're still going to take the derivative, but let's go ahead and evaluate it. According to the first fundamental theorem of calculus, this is the antiderivative evaluated at g minus the antiderivative evaluated at h. But then, of course, we're going to go ahead and take the derivative of this, which it's a sum and difference rule, but we're doing chain rule for every single one. This is going to be f composite g times the derivative of what's inside, which is g prime of x, minus f composite h times the derivative of what's inside, which is h prime of x. And that is another example of second fundamental theorem of calculus. Hope that helps.